Now let us see about the overview of data structure. The data structure can be broadly divided into five groups. One is non-linear and linear, then searching, then sorting, then algorithm analysis, in which the data structure can be mainly used the two categories, linear and non-linear. Under the linear data structure, again it is classified into three and more than three groups. One is list type data structure, and another one is stack organization or stack type data structure. Then the Q is also under by the linear data structure. Q can be broadly divided into circular queue and DQ, in which the list linear data structure can be divided into two groups, broadly two groups. One is singly linked list and doubly linked list. When we go for the non-linear data structure, again it is classified into three groups. One is network types of data structure, and another one is the tree type of data structure. The third category is the graph type of data structure. These three data non-linear data structure can be classified into three groups and under by the category of non-linear data structure. When we go for the searching, again it is divided into two. One is breadth first search and another one is depth first search. When we go for the algorithm analysis, it is again be divided into two. One is time complexity and space complexity also. These two categories are under by the algorithm analysis. And then we go for the their sorting in the data section. It can be classified into broad two categories. One is internal sorting and external sorting. Some of the few examples are given, and the quick sort, burst sort, tree sort, bubble sort, cascade merge sort, bucket sort, linear sort, integer sort, heap sort, and some quick sort. Many sorting techniques are available. Now we look into the definition of sorting. This is an operation. It segregates items into groups according to specified criterion. Now let us see the A. A is a set of a group of elements or collection of elements. The first one set is an unsorted array. Uh, Array of elements are arranged together in a particular set named as A. When we go for after sorting, after applying the sorting technique, the set A can be looked into like this. Uh, uh, 0, 1, 1, 2, 3, 3, 4, 5, 6, 9. Next, the sorting is nothing but it is an ordering. The sorted means it gives the meaning of the sort order based on a particular way. Generally, the collection of data are presented in a sorted manner. Examples of sorting. Words in a dictionary are sorted and the case distinctions are ignored. The second one is files in a directory are often listed in sorted order. Uh, the third category, the index of a book is sorted and a case distinctions are ignored. Uh, Many banks provide statements that list checks in increasing order by using the check number. Next category, in a newspaper, the calendar of events in a schedule is generally sorted by date. The next, musical compact disc in a record stored or generally sorted by recording artist. Why we need to sort all these things? Let us imagine finding the phone number of your friend in your mobile phone, but the phone book is not sorted. How it difficult to search a particular name? Suppose the name is not in particular order, arranging in a particular order. Let us see now review of complexity. Most of the primary sorting algorithms run on different space and time complexity. When we go for the time complexity is defined to be the time the computer takes to run a program or algorithm in our case. When we go for the space complexity is defined to be the amount of memory the computer needs to run a particular program. Next is the complexity in general. It measures the algorithm's efficiency in internal factors such as the time needed to run an algorithm. Some of the external factors are listed. so not related to our the complexity, the size of the input of the algorithm, speed of the computer, and the quality of the compiler. Next is some of the symbolic notations which are used when we are going to analyze the particular algorithm of a particular problem. There are three categories: a big O notation of n. N is nothing but it is an input size, and then next big omega of n and big theta of n. An algorithm or function t of n is an big O of f of n whenever the t of n's rate of growth is less than or equal to f of n's rate. When we go for an algorithm or function t of n is big omega of f of n whenever t of n's rate of growth is greater than or equal to f of n's rate. An algorithm or function t of n is big theta of f of n if and only if the rate of growth of t of n is equal to f of n. Next, the different types of sorting algorithms which are most commonly used in our real world problems or real world situations. There are many and many different types of sorting algorithms, but the primary ones are listed: the bubble sort, selection sort, insertion sort, merge sort, pick sort, cell sort, radix sort, swap sort, and heap sort. Now let us see the one practical example for this bubble sorting algorithm. The basic idea behind this, the idea behind of the bubble sorting is bubble in a water. Bubble in water moves upward. Why? That you have to think about it. How? When a bubble moves upward, the water from the above will move downward to fill in the space left by the bubble. The bubble sort example. Let us consider the two elements, the first two elements. Bubble sort compares the numbers in pairs from left to right, exchanging when necessary. Here the first number is compared to the second, and as it is larger, they are exchanged. Now the next pair of numbers are compared. Again, the 9 is the larger, and so this number is also exchanged. In the third comparison, the 9 is not larger than the 12, so no exchange is made. We move on to compare the next pair without any change to the list. Then the 12 is larger than 11, so they are exchanged. The 12 is greater than the 9, so they are exchanged also. The 12 is greater than the 3, so they are exchanged. The 12 is greater than 7, so they are exchanged. The end of the list has been reached, so this is the end of the first pass. The 12 at the end of the list must be largest number in the list, and so is now in the current position. Now we start a new pass from left to right again. The first pass we can compare with these two. If it is in the greater than value, we can apply the swapping or exchange the values. Then keep on exchanging all the values and sort the numbers according to that. So we can get all the each pass has some exchanging the values between among the group of unsorted elements. Now, uh, which number is definitely in its correct position at the end of the list. That is the 12 is the position. How does the number of comparisons required changes the past number of increases in the previous given example. It is 8 comparisons. And how does the algorithm know when the list is sorted? It is the 8 value. What is the maximum number of comparisons required for a list of 10 number? That this space time is given for you for discussing. You can compare with the answer and analyze it and discuss it with your faculty. Any queries, please. Thank you.